Thank you. All right, so are we okay with number two? All right, good. What about number three? Let's take a look at number three. Number three states, if an object is at rest, can we conclude that there are no external forces acting on it? Well, if object's at rest, that doesn't always mean there's no force acting on it. Right? There could be external forces acting on it, which cancels out. So the net force is zero. Okay? So we'll say no, obviously not, right? An object can have multiple forces acting on it, right? And still be at rest if all the forces cancel out. So the net force is equal to zero. All right. What about number four? What about number four? Consider an object given an initial velocity of v naught. So since it's an initial velocity, it's going to be moving at a constant speed in a straight line. Right? And immediately acted on by two forces. So as soon as the velocity is given, two forces are acting on this object now. Now, we don't know the directions of this. We just know the two forces are acting on it. Is there any way that the body can move at a constant speed? And the answer is, of course it can. Why? What if the two forces acting on it are acting in the opposite direction, so they cancel out? And since it's already in motion, it's going to stay in motion as long as your net force is zero and acceleration is zero. So it's going to stay at a constant speed and at constant direction too, right? So for part B is also true. Of course, it can stay at constant velocity too. As long as your net force is zero, it's going to stay at this velocity v naught, right? What about, is there any way that the velocity could be zero for an instant? Yes, that can definitely happen. So if it's already moving at a constant velocity and you have two forces acting on this thing in the opposite direction, what's going to happen? It's going to eventually slow down to zero, and then it go the opposite way and faster the opposite way. So instantaneously could definitely happen. Can the velocity be zero continuously? Right? Now, this is kind of unfair because they said two forces. We don't know what kind of force it is. Is it constant force? If it's constant force, there's no way. Because once it stops, it's going to have to go the opposite direction. It's going to change direction, go the opposite way. But if it was a varying force, so the force goes like slower, smaller, then I guess you can stay at zero, but that's kind of cheating, I guess. So continuously, I'm going to say no if the forces are constant. Okay. However, if the force can vary or you could change, then I guess it could possibly be possible. Right. What about number five? Can an object exert a force on itself such that the object will be accelerated? Can you push a car from inside of the car? Like right now, let's say your car broke down and you want to push your car off the road, but well, it's raining out there. I'm not going to go out and push the car outside in the rain. So I'm going to be smart, and I'm going to push my car from inside the car, and I'm going to push on my dashboard. Would it move? No. So the internal forces cannot really make objects accelerate. That's like same thing as saying, like, if I push on my left hand with my right hand really hard, am I going to slide to the side? No, that's not going to happen. So internal forces cannot make objects accelerate. Okay, only the external forces can make objects accelerate. All right. All righty then. Now I will do page 3. Now page 3, starting here, I have this pre-recorded because I'm gonna have to like repeat everything I say. It's gonna be boring. I'm gonna stop the recording here.